Welcome to Experiments in Random Walk and Wiggle Walk. In this lab, you're going to be writing a program that lets you experiment with two different types of turtle movement. There's the random walk and the wiggle walk. And these movements will be useful to us because they model behaviors that we'll be using later in the semester. Today we're going to use them to model behaviors of different types of owls. Okay? There are two other NetLogo video lectures related to this that are part of your video summaries and should be watched before or during the making of this model. The first one is NetLogo and the random walk, and the second one is NetLogo and the wiggle walk. Those two videos go into way more detail on how to create and use the slider and also how to control the value of variables. This video will just touch on those briefly. And you'll see when you finish your model, it should look a bit like this. Okay, I'm going to skip through all of the instructions right here. You should read through these before you start any model, so take a minute to do that if you haven't. And let's look at the grading rubric. You get 2 points for submitting your document with the correct file name, either w4.firstname.lastname.nlogo or random walk wiggle walk. You also get some points for a graph, and we'll talk more about that later. The first few lines of your code are worth 2 points. You need to put your name, the date, your school, and the assignment name. You also get 2 points for commenting on each part of your code and telling what it does. So make sure that as you copy the code, you also pay attention to what I tell you each part does, because you need to write that down in your code. You may need to look back at it and use parts of that code for future models. You're going to get 3 points for setting up your sliders correctly. We'll come back to that later. You get 5 points for your program running correctly. This means that your world is cleared, you have a circle centered at the origin, and it'll be drawn with a radius specified by the radius slider. And that when you click, or when I click random walk, the walker starts in the center, and when I click wiggle walk, it also starts in the center, and they will walk differently depending on the procedure that you program for them. We're going to be doing some data collection with owl types. I will assign a type of owl to you, and you're going to get 4 points for having your complete data sheet, including the 40 experiments that you run, and finding your averages, and then finding the averages of classmates who have different owl types than what were assigned to you. You get 2 points for creating a graph of random walk, and we'll talk more about that later. So this is your data sheet. You need to make sure you have this with you when you finish the model. And this is your graph sheet, which you'll use as well. Okay, so let's go ahead and open up NetLogo. Take a few minutes and fill out your name, the date, the school, and the name of the model at the top. I'm going to walk you through the setup and all of the other procedures, and do pay attention to what each of them do. As you copy them down, make sure that you create comments in them that tell what each specific line of code does. So for instance, in create turtles 1, I would say it creates 1 turtle. This is going to be very helpful for you when you go back and you're writing your information section, or you're asked questions about what your model does, or you need to use parts of the code again. You can remember what each thing did. Okay, so we'll start with the setup. We have 2 setups. We've got clear-all, and then we have reset-ticks. We've never used that before, but we're going to start using something called the tick function. Ticks are counted up here on the interface, and that's going to be our sense of time in this model. We're going to ask our turtles to set their color to red, set their pen size to 1, and set their actual size to 3. This will help us see them a little bit better. We're defining our variable angle by using let angle and we want our angle to equal 0 at the beginning. Then we've got repeat 360, which means that this command inside the brackets here will be repeated 360 times, where it picks the pen up, sets XY at 0, 0, sets heading to angle, that's our variable, forward radius. Notice forward does not have a number, and we also didn't use a variable there, so we're going to come back to that. That's going to be very important. Pen down, forward 10, and then set angle, angle plus 1. So every time this runs, we're starting at 0. Every time it runs, it's going to increase the angle value by 1. After it's repeated that 360 times, then pen up, set XY 0, 0, set color green, and pen down. This part right here is going to draw us a circle, basically. And the circle will be as big as the radius slider right here tells us. We'll come back to that in just a second. Okay, and then that procedure is going to end. So go ahead and go in your interface, create a setup button. When you click setup, you may get something that looks similar to this. That's because our code is telling us nothing named radius has been defined. So we're going to add a slider, and we'll name it radius. Go ahead and set the minimum for the slider at 0 and the maximum at 180. Increment at 1. Okay, so if we do setup, you'll see it's still not working, and that is because of some stuff that's going on later in our code. So the next procedure you're going to copy down will be random walk. So in order to random walk, we're asking the turtles to set their heading and then in parentheses random 360. What this means is that the computer will randomly choose a number between 0 and 360. So between 0 and 359 are possible numbers for it to set its heading to. That's going to make the turtle walk in a random direction every time this repeats. In order to get this procedure to stop, we have modified it into random walk with auto stop. And I'll come back to that in just a second, but for a moment I want you to enjoy this adorable picture of a hedgehog lapping milk. Oh, wasn't that adorable? Okay, so to random walk with auto stop, we're going to define another variable here, that's let, and our variable is going to be dist, which is short for distance. Don't type the whole thing in. Shorthand is very useful, and sometimes the computer recognizes full words. So we want our distance to start at 0, and then we're going to ask our turtles to set their heading random 360, so they'll pick any direction between 0 and 359. They're going to go forward 1, and then they're setting their distance to the square root of whatever their x coordinate is times that x coordinate plus whatever their y coordinate is times that y coordinate. Make sure you note there's an open bracket here and a closed bracket, then an open bracket, closed bracket, open bracket, closed bracket. You don't really need to understand the math behind this, just understand that it works. So it's basically increasing it by or changing the distance based on its new x coordinate. And then it will show the distance. One of the most important things that we're doing with random walk with auto stop is creating a conditional. So we can actually get the computer to do something if one condition is true. So we want it to stop if the distance that the turtle is greater than the radius of the circle. So we don't want it to go outside the circle for the random walk with auto stop. So to do that, we're going to type in the same procedure, if distance is greater than radius, note the spaces, stop in brackets. So we're telling it if this in parentheses, then do what's in brackets. After all that's done, we're adding the word tick, and that's going to increase the tick counter right here. Okay, so we've got a random walk, we've got a random walk with auto stop, and we have a setup button and a radius button. Let's go ahead and add a random walk with auto stop button. And I'm going to click forever on this button. Okay, let's click setup. Still nothing, because we've got one more procedure to do. So this one, every time the turtle takes a step, it randomly picks a direction. In the wiggle walk, it is going to go right a certain amount, then left a certain amount, and then forward. So it's turning, then turning back in a direction, and then forward. You'll see we put random, and instead of a number, we have wiggle right and wiggle left. We're going to make two more sliders. If we go to our interface and change to slider, we can click add. Wiggle right. You want your minimum for this one to be 1 and your maximum to be 180. 180. And go ahead and take a minute and create a slider for wiggle left. Okay, I did mess up on the wiggle right, so I'm going to click edit and nope, we're good. Oh, I messed up on the radius. So go ahead and click edit. It should go to 200, a maximum of 200 for the radius. All right, so now we have a setup button, and you'll see now it's working. Our code thing is no longer red. We're almost good to go. We can do random walk with auto stop, and you'll notice that when it gets to the radius, then it will stop. Just like we said, if distance is greater than radius, then it stops. And we can count how many ticks that took. That's going to be very useful for our experiment. We have to add one more button. Oops, not a slider. And that would be our wiggle walk button. I am going to edit or select these and move them so that they're all nice and neat. Somewhere. Unselect that. Go ahead and take a moment and straighten out your buttons and sliders and line them all up neatly. At this point, you're probably looking at your interface and saying, okay, I've got mine, but it doesn't look like hers does on the screen. What you need to do is right-click on the interface, click Edit, and then change your max P core and your max Y core to 200. That should automatically change the minimums to -200, and change your patch size to 1. This is going to make it a little bit easier to see as we run these experiments, and then click OK. Basically what you're going to do now is be assigned a type of owl, and you'll run experiments for that type of owl. Let's see. Okay, so you're going to perform 40 experiments. You're going to be assigned either barn, long-eared, snowy, or screech owl. After writing your program, you'll perform 10 experiments with each of the 2 radius settings required by your owl top for each of the 2 walks. So for instance, if I were a barn owl, I would set my radius to 10, and I would try left 90, right 90. I would do that 10 times. Then I would set my radius to 100, and I would try that 10 times, and so on. Okay? Oh, and I would do that for my left sorry. I would do that for the random walk and for the wiggle walk. So that would end up being 20 different times. Once you finish this, your data will go in your data table, and you'll see here you've got your random, random, wiggle, wiggle. There's one more thing that we need to try to add to our code before you can do this successfully. Okay, before we can be successful with our code and finish this, we do need to edit the wiggle walk button and click forever so that it will run forever. You're going to just have to watch on your wiggle walk how long it takes for it to get to the radius. And if you have questions, let me know. Good luck.